Let us first look into the code which is violating the single responsibility principle. Look at this class srp bat.java. Okay, so this class has got three methods: calculate total, print invoice, save to db. If tomorrow there is a change in print invoice function, some developer will be doing a change in print invoice, and there is a high possibility that calculate total or save to db might get affected. And this is often observed that when a modification is carried out for a specific functionality, some unrelated functionality is affected. This is a very common phenomena. Whoever is doing software development, they know this. So in order to avoid this kind of errors creeping in whenever there is a change in one functionality, it is better to break this class into smaller pieces. So let us see how this can be achieved so that it does not violate the single responsibility principle. So look at this code now. Now this one single big class is broken into three classes now. So first is invoice class, which is doing just calculating the total amount of the invoice. Then another class called invoice printer, this is doing the print job. And the third one, invoice repository, it is saving invoice to the database. So now whenever there is a change in printing function, only the invoice printer class will be modified. Invoice and invoice repository classes are not going to get at all affected. The second principle is open close principle. What does open close principle say is a class should be open for extension and closed for modification. Why closed for modification? Because a already tested code running in production, if it is changed for adding new functionality, then there is a high possibility that existing functionality may also get affected. So how can that be achieved? So this is, say, let us look into this code, class area calculator. So this class area calculator is trying to calculate area of different shapes. Okay, and it has got just one big function called calculate. Within this calculate we have if then else. Okay, so it is checking if it is a circle, then apply one formula. If it is a rectangle, apply another formula. If tomorrow we want to calculate the area of a triangle, then we add another if else block and then add the functionality for the triangle area calculation. But because we are changing the existing code, there is a very high possibility that the code inside here or the code which depends on area calculator class and calculated function may get affected. So how to solve this kind of problem? Let us look into a good example of open close principle. So what we do here is that instead of having direct class and all function implementation, we first declare a interface called shape. In shape interface there is a function called area, and we dedicate one class for each shape type. Rather than having a one big god function in a class which takes care of all kind of shapes area calculation, here we distribute that code into classes. So whichever shape want to calculate area, that shape will implement this function called shape. So class circle implement shape, class rectangle implement shape, and then there is a class called area calculator. Okay, so there is class called circle, then there is a class called rectangle, and then area calculator. So here we have divided that one function code into different separate, we have divided that one function code into separate classes. So now each class knows how to calculate area for its shape. If we want to add the functionality to calculate area of a triangle, then instead of changing any of the existing class code, we will be writing another class called class triangle. Class triangle, implement shape, and then the area. Now look at this. New functionality has been added without changing any existing code. So what we are achieving here? We are protecting existing tested code running in production from modifications, and thus we do not want to go into an endless loop where we touch upon a functionality, then create a bug, then fix this bug, then create another bug. So that endless loop we want to avoid. Okay, now let us move to third principle called Liskov substitution principle.